Welcome to The Explainer. Today, we're diving into an absolute mind-bender of a topic. We're going to look at planetary momentum and, well, some seriously heavy physics. But hey, don't worry. To make the totally apocalyptic destruction of this thought experiment just a little easier to digest, we're exploring the whole thing through this adorable, blocky 3D style. So buckle up, because we're in for a wild ride.
Let's start right off the bat with the ultimate hypothetical question. What if, for just one single second, Earth suddenly stopped with absolutely zero warning? I mean, no gradual slowdown, no squealing tires, just bam, a dead stop. What exactly would happen to you? What would happen to the oceans, to the entire planet? Well, let's find out.
Section 1. The speed you don't feel.
You probably feel like you're sitting perfectly still right now, right? Maybe you're relaxing on the couch or just chilling at your desk. But scientifically speaking, you are absolutely not. Okay, let's dive into this. Check out this massive number, 1670 kilometers per hour. If you happen to live anywhere near the equator, that is exactly how fast you're currently hurtling through space as the Earth rotates. To put that into perspective for a second, you are moving significantly faster than most commercial airplanes right now, all while supposedly sitting completely still. Crazy, right? Now, if you're thinking, well, I don't live right on the equator, don't let your guard down just yet, because you're still zooming along. Even in a place like India, which is much further north, you're still moving at over 1,200 kilometers per hour thanks to the Earth's rotation. This incredible, completely invisible speed applies literally all over the globe, no matter where you happen to be sitting. So, the real question here is, why don't we feel like we're constantly strapped into some supersonic roller coaster? Well, it all comes down to the beautifully easy physics of a relative speed. We don't feel the movement because literally everything around us, the air, the buildings, the oceans, the ground itself, is all traveling at that exact same speed. It's like we're all just moving together, perfectly in sync. Section 2, the sudden 1-second stop. All right, let's imagine the impossible actually happens, and the spinning rocky core of our planet just freezes in place. But here's the massive problem. You don't stop. The planet's rocky crust might have hit a metaphorical brick wall, but the fundamental law of inertia dictates that objects in motion absolutely want to stay in motion. So your body, your coffee cup, the air, the oceans, everything that isn't bolted deep down into the Earth's bedrock just keeps moving forward at that original, terrifyingly high speed. In that very first fraction of a second, you and everything not permanently attached to the deep bedrock would be violently thrown sideways at hundreds of kilometers per hour. We're talking buildings instantly collapsing like tiny toy blocks. Cars, trees, and people just swept away in a literal blink of an eye. It would honestly feel like a planet-wide impact event hitting every single continent at the exact same moment. Quite the contrast to our cute little 3D visuals, right? Section 3, supersonic winds of destruction. Now, what's really interesting about this slide is that the destruction isn't just happening on solid ground. We actually have to look up. You see, the atmosphere has mass, which means the atmosphere has momentum, too. So the solid Earth might have slammed the brakes, but all that air, it just continues rushing across the surface. This generates supersonic winds that are vastly stronger than any hurricane humanity has ever recorded. Picture a wind so unimaginably powerful that it literally just shears whole cities flat in a matter of seconds. Yeah, even in our adorable 3D toy model, those little block trees wouldn't stand a chance against that kind of physics. Section 4, momentum and mega tsunamis. Now, if you thought the air was a massive problem, just wait until you remember how much of our planet's surface is covered in incredibly heavy ocean water. All that water holds massive forward momentum. So when the Earth stops, the oceans definitely keep moving, violently crashing into the continents. We're talking about mega tsunamis towering way taller than skyscrapers. Entire coastal cities would be totally wiped out and swept clean off the map, with vast stretches of land just completely flooded in mere minutes. Picture those massive, cute 3D waves overwhelming tiny toy-like coasts. It's a truly adorable apocalypse, for sure. Section 5, the violent planet restart. All right, remember the entire premise of our explainer today. The Earth didn't stop forever. It only stopped for one incredibly long, incredibly destructive second. So let's walk through this whole 1-second sequence. Step 1, the sudden stop, where unchecked momentum violently throws everything forward. Step 2, supersonic chaos, as those incredible winds and giant ocean waves completely sweep the surface. And finally, step 3, the violent restart. Just when you think the absolute worst is over, the Earth violently jerks back into its normal rotation, meaning everything gets hit again. This sudden, intense stress on the Earth's crust would cause massive, planet-shattering earthquakes. It is basically the ultimate double whammy of basic physics.
Section 6, a physics reality check. Okay, take a breath. Before you start nervously bolting all of your living room furniture to the floor, let's just look at the actual science of this scenario. Stopping a planet of this size and mass requires a practically unimaginable amount of external force. So it's incredibly reassuring to know that this absolutely cannot happen naturally. There's no giant cosmic brake pedal out there in space. However, if it somehow did magically happen, this level of sheer physical trauma would undoubtedly trigger a near-instant mass extinction event across the globe. No question about it.
And that brings us to our final thought from the source material. So next time you feel like you're standing still, remember Earth never stops. I really hope this explainer gave you a newfound appreciation for the incredible, invisible physics happening right beneath your feet every single second of the day. You are currently riding a massive rock speeding through space at over 1,000 kilometers per hour, perfectly balanced by gravity and inertia. So, if we're entirely at the mercy of this invisible, unstoppable momentum, what other cosmic forces